Actually, I'm pleasantly surprised to see so many of you here for the first talk after a party. Thank you very much. So, about a month ago, I think I've lost track of time a little bit, I was at KubeCon EU in Valencia, and wandering the exhibition halls and looking at the schedule of talks, it really amazed me that projects like Kubernetes have now become such an essential part of many application stacks. It's actually quite hard to imagine building anything without it. And this, I've reached the end of this slide, and this list of sponsors from KubeCon EU is still going, which shows you how many booths and various vendors there were. And there we go, it's still going. You get the idea, there's a lot out there. It's a lot of applications and vendors trying to help us with that. I think this image is probably familiar to many of you, the infamous CNCF landscape image. It kind of struck me as well that fairly quickly that some projects such as Kubernetes, and you can add to this list many common programming languages and other things we use very regularly, have become so complicated that we need to add dozens of other tools and dependencies to use them efficiently and effectively. And this is the CNCF landscape picture. I had to zoom out 80% to fit it on the screen. And now there's even a special interest group, a SIG at the CNCF, to help people navigate this. That's how complicated it's become. There has been a long era of relatively affordable cloud computing resources, and this increased the temptation for us to keep throwing more cloud-based resources at problems, as there was a relatively minimal impact on cost, and we gained a lot of advantage and flexibility from doing that. We didn't want to repeatedly write boilerplate code, so we used frameworks and other dependencies to hopefully focus on what was really important. We needed tools to help us handle demand, tests, build applications, orchestrate applications, create infrastructure, manage infrastructure, etc., 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 etc. To a point where we kind of started to lose direct insights into our technical stacks and what was happening inside of them. So we added more and more tools to help us understand what we had lost sight of. This is, of course, where observability comes in, but also efforts around security, another active project inside the CNCF at the moment, and a big topic at KubeCon was about bringing security insights to these applications. Things like the software bill of materials, rather comically abridged to S-bombs, which maybe kept laughing, thinking people were swearing, but that's a whole other conversation. And now, for various reasons, we find ourselves in a moment where we're actually starting to question the financial impact to businesses of this growth and reliance of all these cloud services. And there are now more tools to help us monitor and streamline the costs of those. Even things like Terraform now have some open source projects and some commercial projects that give you an indicative cost of what rolling that out might be. There's even now an entire sub-foundation of the Linux Foundation called the FinOps Foundation, which aims to help increase skills and awareness and techniques and practices around efficient cloud usage. But there's another unintended side effect of this cloud proliferation of services and frameworks and this kind of throw another service at it development. And that's what I'd like to talk about today, and that's an impact to the environment, to the world around us. It's quite easy to forget sometimes with all this abstraction that behind all this code, all the pushes we make, all the tools we use, the builds, the applications and processes is actually real hardware running in physical locations somewhere. Why am I here and talking about this topic? My name is Chris Ward. I go under an online nickname of Christian Chiller a lot because my real name is so common, it's impossible to find me. So I use a nickname so you can actually find me. I'm the technical writer at Chronosphere. You can see my Twitter handle here and also the Slack channel if you want to ask any questions. I work on the documentation there, a lot of the tech blogs, and also host a new video series we started. I'm fairly new to observability. Chronosphere offers its own kind of take on observability tooling. But why did I want to talk about this topic with all that in mind? Well, actually, it was after a conversation with someone from the FinOps Foundation at KubeCon. And I've always had a bit of an interest in helping developers and encouraging the development ecosystem to think differently about what we do. And I used to actually work in Australia in technology for environmental organizations, mostly in jobs that were then called webmaster. So there's always been a bit of a thread of interest in the topic. And then this conversation with Ben here really sparked something in my mind, even to the point that I asked Jason, the organizers here, if I could change my talk about a month ago. And thanks to them for letting me do that. And I hope that my kind of naivety and enthusiasm on the topic doesn't show too much and you find it interesting. So how big is the problem? A lot of this at the moment is hard to get exact numbers. We have to do a lot of back of the envelope conjecture and kind of manipulation a little bit to get some numbers that are useful to work with. And there's a few sources I will list as I go. So bear with me. There's a little bit of extrapolation you have to do here. So according to, actually there was a BBC article which then references other reports, and this is mostly taken from a couple of sources, to get to around 3 to 3.7% of carbon emissions. This is actually almost the same as the airline industry, which people pay a lot more attention to in this scope, but actually is probably harder for them to change that in some respects than for us. And data centers on their own account for about 1% of emissions, so actually a fairly high percentage of that. But of course, internet usage, and I will question what that means in a second, is increasing rapidly. There's now about 50% of the global population using the internet, and that's obviously growing very, very quickly. And I kind of think when these surveys refer to the internet, it's a little vague. What does that really mean when we consider the wider usage of the technology we create? So I would probably say this number is a lot higher, especially if we consider a lot of that indirect infrastructure that a lot of us work on, that people use on a day-to-day basis by billions of people. So if you attended Adrian Cockcroft's talk yesterday afternoon, we did talk before this event and kind of figure out how we could overlap on some similar topics. He mentioned to me this cloud carbon footprint project as a good tool I could use to illustrate some of my thoughts and here for this talk. It helps you look at the carbon impact of the sort of three main cloud providers, AWS, GCP, and Azure, but it is open source. It's mostly looked after by ThoughtWorks, so you can make contributions to add other sources, I guess. And as a bit of a recurring theme here, it's actually a reasonably complex application in itself, and of course has its own overhead, which is worth bearing in mind, but I think in this topic, sometimes you just have to start somewhere, which is kind of why it's useful. How does it calculate to calculations? I don't want to go too much into this number. You can find a lot more detail on their website, the cloudcarbonfootprint.org. But this is roughly how it calculates some of the numbers I will show. Okay, I'm going to be bold and attempt to do a very quick demo. Yeah, so this is it running locally on my machine with mock data. Just to give a quick idea of what it looks like when you start it. It's a node application. You can see the different cloud providers. You can see the accounts on those providers. You can see the various services. You have a date. And on this chart, which we're kind of used to, we have emissions over time, each day with metric tons, kilowatt hours, and cost. It then gives you like a rough estimation of what that kind of means to figure that out. We have breakdowns here by region, service, and account. I find the service one kind of most interesting. And then actually another interesting part is this intensity map. So by each provider, which data centers are the best or worst to be using. And this is actually one of the other areas I find quite interesting. So this was kind of helpful, but I wanted to try and measure something myself. So I built a demo application. It's a little hard to build a very effective demo for this because often you need to track it over time to get a long time to get a good idea. And also, I'm not really an engineer, so building a very complicated application is not my forte. So I went for something quite simple, and then I made a lot of estimates about how I would increase the numbers I got out of that to get something more realistic. So I just made a node application that I then measured at various stages. I kind of made some assumptions that there would be an average of 1,000 concurrent users over a year to get to my final numbers. I ran it primarily in EU data centers, mostly just because that's where I live. I used GCP because I understand it the most. The application that I made used Cloud Run, Cloud SQL, and here's where things get interesting, then all the other services that were necessary to support those. So this included, I'm going to actually find the list, Bigtable, the artifact registry, logging, and billing. All these services that are not actually central to what I'm doing, but are still running. This kind of gives you the theme of the talk here. So here's what I ended up with. Ignore the values, because as I said, this was running kind of low payloads, but mostly I'm interested in looking at the scaling here. So right at the bottom is where I literally just ran node, JavaScript, console.log, hello world. Pretty minimal impact, still something, but fairly minimal. Then as it ramps up, I added Express, the sort of infamous JavaScript REST API framework. And then again, just with an API endpoint, console.log, hello world. It adds about 57 packages. Obviously, JavaScript is somewhat infamous for this. And it jumps up quite a bit. Then, when we get to the top, is where I changed things a bit and added a SQL database. And instead, I loaded just 3 rows from a database table and displayed those instead. And it jumps up quite a bit here. The next one is where it surprised me. I added a just wasting time function that did a lot of kind of unnecessary mathematical processing just to kind of simulate a heavy workload. And it actually didn't make a lot of difference, which sort of surprised me. Maybe it doesn't surprise others, but it surprised me. And then the other interesting thing is I then left it for a few days and it doesn't drop down to 0, which is weird, and I don't really know why, but that surprised me as well. I don't know what was going on there. Something kind of running in a background, I guess, that I'd forgotten about. The services may or may not surprise you, but it surprised me. By far, the biggest consumer and impact to carbon emissions here was Cloud SQL. Probably isn't surprising. I actually used to work in content management systems and remembered that you always had to put caching and all sorts of optimization in front of SQL databases. But considering it was doing so little, it's actually kind of surprised me. But maybe I shouldn't be surprised. So, what does all this mean? So again, I took all those numbers to get kind of a more real-world number, and this is what my little application running over a year would have an impact of. So about one-way flight from London to New York City, about 140,000 phone charges, and then to sequester all that carbon, about 20 seedlings grown for 10 years. These numbers don't effectively really seem that high, but bear in mind this was a very simple application. Multiply those kind of numbers by real-world applications running, hundreds of thousands, hundreds of millions of applications running all around the world all the time, and you start to see where these numbers increase quite rapidly. And so what? I've never been one that liked to just give a talk that told the audience about a bunch of problems they had to worry about, but didn't really give any advice about what you could do about it. So here's a few ideas. Now, obviously the most obvious thing to do is streamline services, make more efficient services. This is Monitorama, this is an observability conference, the perfect place to learn about that, of course. In fact, you're probably already doing it, or you know how to do it, or you want to learn how to do it, and many of the tools in this ecosystem will help with that, and then indirectly with environmental impact. So an inefficient service is quite often the source of that biggest impact, and one of the easiest targets for us to target, and have other benefits as well, of course. So in addition to that, obviously some other things we can think about are using compiled code or compiled languages. I used a very unoptimized JavaScript. There's obviously much better ways to build some services than that. Thinking about things like dependency updates, of course, that might fix memory leaks or make things more efficient. Or more interestingly, actually providing features if you're kind of a provider that help your customers. So an interesting one at Chronosphere is we have a feature that, or several features, that let customers optimize the metrics they're storing with us. So this helps everybody in a bunch of different ways, but indirectly, because we're reducing impact on our cloud hosting, it also reduces that environmental impact for us and customers as well. So, you know, there's sometimes you can offer features that think about these things as well. Thinking a little bit broader, there's some other aspects we can also look at. Being selective with providers. Certain providers are better than others. And then if you think back to that map we looked at, greener data centers. This uses this term PUE, power usage efficiency. And if you saw Adrian's talk, I think he covered that it's not a perfect calculation, but again, it's kind of one of the better ones we have at the moment. But also in terms of location, not just greener data centers, but location to your users. If you have a user in Europe and you send all their data to America, obviously there's other reasons that's not a good thing to do, but that transmission also has an impact. I actually found entries of this in the dashboard of transmission costs. So this ties very nicely into CDNs, of course. These are a very kind of quick win to reduce some overall impact as well, and again, other benefits, of course. I was pleasantly surprised to see that pretty much all of those three providers provide their own sustainability tools. They require running applications over a long period of time, so I couldn't really use them. And of course, I would think a lot of people are using hybrid clouds anyway, so the other project helps us aggregate across a bunch of different sources, but they also do have them. And I'm starting to wonder if there might become something very soon where customers might start asking for impact reports, whether this is because they want to or because certain regions in the world start demanding them. It's actually something to start thinking about. So if we can already start thinking about them and working towards that, we're getting ahead there. Don't forget the front end. This might be a strange thing to mention at an observability conference, but the front end is of course a fundamental part of many applications and probably already part of your observability stack. But the front end is a special case because it doesn't just affect you as a provider. It also affects your end users because they're accessing a version of your application. So take all those impacts we mentioned earlier and multiply them by quite a large amount, and it's having a much bigger impact on things. We all know and joke about how browsers use up so many resources on machines, and that means something, of course. That's electricity. But fortunately, the front-end community has actually been thinking about this for some time and is a little bit ahead, actually, in regards to other parts of application development. And here's a few useful links. The CSS Tricks blog was actually one of the first things I read a few months ago that made me slowly start thinking about this. And they have a whole series on optimizing front end for reducing impact. And of course, that indirectly is an environmental impact as well. There's also the website Carbon Project. I found several books on the subject, and this Tom Greenwood's, I think, was from A List Apart, which is always a very good source of information for web design, especially. And then sustainablewebdesign.org, another really good list of resources I found. Purely by absolute coincidence, Google even has an event on this subject today. So hopefully if I ever run this talk again, I will watch these videos and bake some of that in. It's kind of a shame that it wasn't yesterday and I couldn't have watched them. So I guess my summary here is reiterating my last point, that I get a feeling that this might become something that we have to do in the near future. So you can get ahead of of that requirement and start thinking about the impact of applications as well. And observability already provides us many of the tools we need to get this information, so we could start building things like dashboards, etc., to start monitoring this now. So if it's not too much of an extra step, why not try, I guess, is my summary. Thank you very much. You can find my personal information here, and if you want to know more about Chronosphere, here's a QR code, or if you don't like scanning random QR codes on a screen, there's a random link instead. And we have t-shirts, there's a PlayStation giveaway, and a bunch of other things as well. So I'll always be happy to talk to you. And thank you very much, and I'd be interested in hearing questions, or at least discussions. I don't know if this is a topic that has concrete answers yet. So.
Yeah, are there any questions? Ooh, man, this is clearly Jason was standing here. Any questions?
Up here.
Oh, there we go. See ya.
So your talk and Adrian's talk yesterday, there was a lot of estimates. What level of confidence do we have around this information? Are we just mostly guessing? Are we off by a magnitude of 1, 2? Where are we in terms of accuracy of understanding the impact?
And then just repeat the question.
Yep. So the question was, how confident are various people interested in this topic about the numbers we have being helpful? I think, especially bearing in mind some of my experience in this sector in the past, is as well that everyone has a different measurement as well. So getting a consistent opinion is also quite difficult. It's not an exact science. It's a problem we know we have, but how we get to knowing we have the problem depends who you speak to. So I think we can be confident in knowing that there is a meaning to those numbers, and high is generally bad, but whether they are completely accurate, I think, will really vary, and there's going to be a lot of different opinions on which values we should use. But I guess I would hope that the general consensus becomes that it doesn't, if you want to care about this topic and move on, using any kind of value is useful, and as long as you trust it and you have the evidence you've read to believe that it's useful, I guess that's enough for you. But I would also assume that if this does become regulated, there will be numbers then that we have to measure more strictly, and whether we like them or not, those will be what we have to follow. And I think this comes up a lot in tech, get ahead of the regulation so you can actually influence something more useful than what governments might come up with. So, and I think Adrian probably went into a lot more detail about some of the problems with some of the calculations as well, and how we can fix some of those. So that's kind of my answer. Oh, I saw the guy in blue first.
If you're trying to compare your own in-house built software to vendors' software, have you thought about how you would kind of benchmark different software offerings for comparison? Is there anything in any of this universe that is a benchmark that you can use?
So the question was, are there any benchmarks you can use at the moment to compare different vendors? I'm not completely sure of the answer to that question, especially bearing in mind that a lot of vendors may not supply anything, so there's nothing to benchmark. If you're running it yourself, which can happen, then you can get your own benchmarks, of course. You could also, if you're in a demo stage, for example, with vendors, you could request it and thus give you, if you're a valuable account, they might give you those benchmarks. You can then compare. I think you could possibly get other indications as well, leading into that efficiency, that if the application is memory intensive and slow, etc., it's probably having other impacts, and if another equivalent isn't, then it's probably having less of an impact. That is, of course, a little bit of conjecture, but that's probably, if you have nothing, you can kind of get a rough idea. We all know there are certain applications we run that really hit a computer. This is obviously on a local level, and those that don't, and we often tend to prefer the ones that don't. So we can kind of do some very rough benchmarking there. But I reckon actually probably the answer I would like to give is start asking for those benchmarks, and then you have them. But that might be a challenge to begin with, but maybe in the future. But, and yeah.
Oh yeah, we're good.
So in your research in the front end stuff, is there anyone working, so like there's new carbon data sources now about generation that are real time, so like what, for a particular location, what's the carbon mix at that moment for maybe hour periods that are being used pretty frequently now for tracking this at the cloud level? Is anyone doing it at that granularity with their front end assets, like using that data and user reported locations to kind of figure out what offsets they need to buy?
So the question was, are there any real-time kind of dashboards on monitoring for the impact, especially on the front end? Yeah, was that? Yeah. Again, I'm not 100% sure, but the interesting thing I found with my research on the demo applications I made is a lot of them currently work off billing data, which is often delayed.
Right.
So
There are new systems are coming along
yeah,
right now.
the front end would probably mean you'd still have to know. There's that in the calculation. There's the embodied emissions, which is the stuff that's harder to know about because you don't always have direct access to it at that moment. But you could probably, take that, extrapolate it, and then build that into the more instant feedback you can get in modern web applications. But I don't know of anything that does exist, but it might. I would actually envisage it possibly does. I just haven't found it because the front-end community moves fairly quickly. So it probably does exist, and I would like to go and find it. So thanks for giving me that to look into.
Cool. Any other questions out there? Awesome. Great. Thank you so much. This was awesome.
Thank you for having me. Thank
A round of applause.